This is the first in a series of videos and an introduction to complex numbers. So what's going on in complex numbers? So consider the equation x squared plus 1 is equal to 0. Does this have any solutions for x? Well, if we were to rearrange this, we'd be looking x squared is equal to minus 1. And we could say, well, there's no real numbers that when you square them, you get a negative number. And so for complex numbers, what we're going to do, we're going to define a number I to be a new number. It's not a real number, such that when you have I squared is equal to minus 1. So this is the property here. I squared gives you minus 1. Also note that if we so that means I squared plus 1 is equal to minus 1 plus 1 is equal to 0. Also note there's actually two solutions now of this equation, that if we square negative I plus 1, so minus I squared be minus 1 squared times I squared plus 1. And so minus 1 squared be plus 1, I squared be minus 1. And again, we get 0. Just as a side comment, there's lots of fun history to complex numbers that I won't go into. Complex numbers really came to the fore in 1500s in Italy, where it's the first time they were being used in the solution of cubic equations. And so at first, people really didn't know what to make of them. That it seemed like they were helpful, they were useful in solving equations, but it's like, well, but what is this? But I should say this is part of mathematical development. There was a point in time at which negative numbers weren't really considered to be okay by the mathematical community. So that's something that's only developed over time. Okay, let me just do a little bit about arithmetic of complex numbers. So for example, so we usually are going to use z. We usually are going to use z as our standard complex number, just like we would often use x as a standard real number. And so we write z is equal to x plus iy. So we're going to kind of split this up into the real part and the imaginary part. This right here is often called rectangular form. Rectangular form of a complex number. Why rectangular form? Well, I'll just kind of say in the future we'll have other forms, like an exponential form of complex numbers. That will be something we'll see in the future. And we write, for example, so for a real part and imaginary part, we would say the abbreviation there are RE of z is x, and IM of z is equal to y. So as a quick example here, if z is equal to 4 plus 3i, the real part of z is equal to 4, and the imaginary part of z is equal to 3. So note the imaginary part of z is not equal to 3i, it's just equal to 3. It's implied there that then you have to multiply that by I to get into things. Of course, some of these could be 0 or negative. So if z is equal to, let's say, minus 2i, the real part of z is going to be 0. It's really a 0 minus 2i right there. And the imaginary part of z would equal minus 2. One more thing to do in this video is that complex numbers add and subtract in exactly the way that you would want them to add and subtract. So for example, if we were to do 2 minus 7i plus negative 4 plus 10i, what we would do is that we would add together the real parts. 2 minus 4 gives us minus 2. We add together the imaginary the imaginary stuff here. Minus 7i plus 10i would give us plus 3i. And of course, there's nothing special here. Change that to a minus. I'm sure you can see what would happen. You know, if we make this a minus, then we would get to minus 4, minus 4, I should say, there would be 6. Minus 7i minus 10i would be minus 17i. And the final thing to do is in this video is sometimes we might want to multiply by a real scalar. And so for that, we need to have 5 times 2 minus 7i. I'm sure we can see what that's going to be. Just distribute the 5 times 2 and 5 times 7i to get 10 minus 35i. Okay, so that's the first video. There will be more to come.